Let's look at identifying the strongest attractive force present in each of these pure substances. Of course, London dispersion will be present in each of them, but London dispersion is only going to be the strongest attractive force if it is a nonpolar molecule. So pause the video and determine whether each of these, or determine the strongest attractive force. And I just want to point out that ammonia, NH3, has a Lewis dot structure that looks like this. This is from Wikipedia, so it also has the bond length and the bond angle. But what we care about is nitrogen has a lone pair of electrons and is covalently bonded to 3 hydrogens. So pause the video and identify the strongest attractive force, and you can use flowchart in figure 7.6 of your textbook to guide you. So if we look at this flow chart, the first question we want to ask ourselves, is the compound polar? And yes, ammonia is polar. It has an electronegative nitrogen, a lone pair on that central atom. It is polar. The next question is, if it is polar, is hydrogen bonding possible? And yes, hydrogen bonding is possible because nitrogen is covalently bonded to hydrogen, and there's a lone pair on our nitrogen. And then the next question is an ionic charge present? And no, it's not, because ammonia does not have an ionic charge. So according to our flow chart, it must be hydrogen bonding. All right, then if we look at our second compound, which was hexane, hexane is made only of carbon and hydrogen. Carbon-carbon and carbon-hydrogen bonds are non-polar. So is the compound polar? No. So London forces are the only attractive forces that will be exhibited by hexane. And then our last molecule is glycine. And notice that there is a positive and a negative charge on this molecule. So if we look at our flow chart, yes, our molecule is polar. Yes, hydrogen bonding is possible. Yes, an ionic charge is present. And actually, opposite charges. Let's see if I can get this down further. Opposite ionic charges are present, which means that it is an ionic attraction occurring in glycine.